Good afternoon, everybody. I know that you're getting up to stretch a little bit, but I hope you give us your attention as you grab that cup of coffee, because this next conversation is with a company that stayed, was born here, grew here, and probably one of the most exciting companies looking into the future. I am with someone who's really helping to shape the future of AI, and he was recognized this morning for doing just that. Ramin Hassani is the co-founder and CEO of Liquid AI, and he was named a Boston Tech Power Player by the Boston Globe. So he got some hardware and I believe a cookie this morning. A scientist at MIT's Computer Science and Artificial Intelligence Lab, known as CSAIL, he has spent his career really pushing the boundaries of what AI will accomplish in the real world. His research focuses on liquid neural networks. And now, through AI, he's turning that research into tangible solutions. And we are about to learn how. So, Ramin, again, congratulations on making the Tech Power Player list. Now, already this morning, AI has been brought up a lot. But for many of us who are not Tech Power Players, when we hear that term, it still elicits hope, fear, uncertainty, a little bit of anxiety. So as we talk about moving AI from hype to impact, I want to begin by asking you, what's the biggest mismatch between the promises of AI and what we can see in real-world outcomes?
So as we see that a lot of our, like AI developers and also AI companies in the world, we are on the race to building the most powerful AI system in the world. And that's such an amazing and exciting opportunity for all of us that blinds us towards like how we are actually achieving and how we are realizing that journey. So hype gets generated by these exciting opportunities that have like an amazing outlook in the future, and but then it becomes, it becomes more and more, the bubble actually grows when you just blindly look at the outcomes and the impacts that this technology can bring for us. And then this race to getting to that point, it just gets us, to really claim more than what we have, or, we're not at that level of capacity that we can talk about it. So how we are getting to that level of artificial intelligence that can change our lives or revolutionize how we do work and build our societies and economy, that part is the part that we have to really pay attention to. Because when I say how to make it, is that, say, for example, are we understanding the AI systems that we are developing? So that's like one of the challenges from the technology point of view. Then are we understanding the markets that we are trying to build and capture immediate value from, And do we understand kind of the implications of this technology in our society, like privacy, security, and accessibility to this type of intelligence?
I'm going to ask you about some of the needs of those specific markets, but I want you to briefly tell us about your founding story. Daniela Roos, who is also on the Tech Power Player list, who was here earlier today, also with you at MIT. Why did you found this company? What was the original goal?
Yeah, so one of our mottos was, we were MIT-grown scientists. We were looking into machine learning done right. We were looking into, from first principle, building machine learning solutions that can solve real-world problems. And that was, us looking into how can we get AI systems that are more efficient, that we can, serve them for doing the job of going beyond the data that they have seen. Because when you train an AI system, you start looking into, you train them by data, on certain data. You collect data, you train these models to get them to work. Now, can they generalize beyond the data they have seen before or not? So these were like fundamental questions from research that we were trying to address. We came up as a result of that with a technology called liquid neural networks. And that technology allowed us to bring intelligence in a way that we understand it on devices. So we were being able to bring intelligence on robots. This was our computer science and artificial intelligence lab at MIT, CSAIL. We were like bringing intelligence on the robots, and then we started seeing like putting these AI type of systems, they can solve econometric problems. Like they can actually look into finance, healthcare, and different kind of places. And then we thought that, okay, so the technology has a lot of promise, and it doesn't consume as much energy as the other AI systems are providing. So it is a very efficient type of machine learning system.
So let me clarify for the audience. This is called edge AI, which means taking the AI out of the cloud into an actual device. And tell us why actually the cloud is not where we want to be in the future.
Yeah, so I mean, there's a space where edge means like when you have a network, you are operating at the edge or the devices of a network. That means, for example, if we are all having a mobile phone that's connected through a network, but the mobile phone itself is a computer. It has a computer on top of it. You can run algorithms and intelligent systems directly on the device. Or you can centralize it and run it on a data center. So the current generative AI kind of solutions that we are seeing, they're mostly getting hosted in massive data centers. And what we are trying to do, because our technology actually had the promise of efficiency, we're trying to bring that technology to the edge. So in some sense, what do you get if you actually bring the intelligence on the edge? First of all, the software is going to run in your hand. You have it in your control. Be it a mobile phone, be it the car that you drive. In the future, cars are going to be different. In the future, laptops are not going to stay as laptop. Maybe we have different form factors. Maybe you're going to have like glasses that are doing the job of a laptop for you. So there's going to be different form factors in the hand of humans powered by intelligence. This is where Liquid comes in, and we are providing that kind of
Does this
solution.
make the AI more secure? What are the benefits? Is it more private? Is it more secure? Is it less expensive?
Yes, so when you bring computation from the cloud, from massive infrastructure, to the edge, there are a couple of advantages that you're going to unlock. The first thing is privacy. As I said, you are going to be in control of that device. Even if you put your phone on offline mode, you still have access to that intelligence. That's kind of the value of this thing. So that means like computation actually happens, in your hand. The second thing is security. So when you're doing autonomous driving, for example, in the case of autonomous cars, you cannot rely on an oracle that controls all the cars in our cities. So each car itself, like each human, is going to be independent of the other one to some extent, so they have control over how they are achieving and they're performing. So the advantage would be security. So that intelligent system would be in control of its decision, and we can monitor these decisions. The last point is cost. As you guys know, like generative AI is extremely expensive. You need to build data centers to be able to train them and maintain them. And even maintaining them and hosting them for people to use it, it's even exponentially more expensive than developing them. When you bring generative AI on the edge compared to cloud, the cost of intelligence goes to a fraction of the cost in the cloud. Why? Because the computation doesn't run on the energy of the data center. The computation happens in your hand with, with a small amount, your battery of your phone. So if the intelligence is actually on the phone.
This sounds great, I think, for company CTOs, definitely CFOs, if you're talking about a cost saving. Can you give us some benefits for, say, the business leaders in this room who know that they have to embrace AI, but they're not exactly sure how and why they need to do this? What are the benefits for the people that are building companies and have to plan for the future?
Absolutely. So I'll say the first factor is cost. When we go to financial services, they are adopters of generative AI technologies. And they are the places where they actually know the prohibitive cost of these systems after development when they put them in the hand of customers. Because as you use these cloud-based AI systems, the API calls are going to be very expensive and exponentially going to go bankrupt basically the whole benefits that you want to get out of it. If you look at companies like OpenAI's of the world and Anthropic's of the world, they are, when you see the reports, they are actually having a lot of, they're not profitable at this moment. They have massive amount of inference costs. And the reason why the inference costs are the most important one than the development costs is because inference is expensive with cloud-based and larger scale models. That's something that the community is working on. They're providing a solution. But if you start, I would call that approach of cloud-based AI for CTOs and people that are in the room, a bottom-up approach. You build a data center, or you call a data center to call your intelligence system. The approach that we are taking is a top-down approach. Think about all the devices that you already have in your enterprise. Whatever you have laptops, you have PCs, you have old phones and everything that is actually have. That can be the entry point for generative AI. So if an employee of yours has a laptop, they can be enabled with generative AI applications. So that's kind of the top-down approach that we're taking. That's from the cost perspective. Right. Then there are sectors that are caring about privacy. So another approach to local and edge AI is the fact that data doesn't leave your enterprise, so data stays with you. So privacy is another application. And the last one that I want to mention is latency-bound kind of applications. So imagine you have to make decisions really, really fast. So let's say, for example, in the case of a shopping center, it's like you're online. You don't want to, when you search a query, you don't want to wait forever for an answer, because some of the challenges of these edge AI kind of local AI solutions is that they are pretty slow. You cannot really get them to perform as performant of the ChatGPT experience that you would get. If you resolve that, then and this is what we've done, basically at Liquid, and we're enabling kind of millisecond level kind of latency. This would allow you to actually perform low latency kind of computation. One last example I would give on a sensible example of the low latency stuff. Imagine, again, in the case of controlling a car or driving a car autonomously, you don't want the AI system to be delayed. You want the AI system to be understanding your commands, but at the same time, does the job really, really fast. So latency, privacy, and cost.
I want to bring up another aspect. We have questions flying in, so I'm going to move us along here. So first of all, we all know that deploying an AI model is about training that model and shipping it. So what's the reality when it comes to edge deployment? And I have two questions that I'm going to combine here. One person asking, can our devices handle this in their current form? Secondly, something that I'm introducing, another factor aside from the privacy and the security, is the accuracy. Because a lot of us, regular people, we doubt the validity of these models. So with all of this, when you deploy edge AI onto devices, talk about the ability to make sure that there's accuracy and validation, and can our devices handle this?
Absolutely. So building foundation models, this class of models, I call them foundation models. A ChatGPT-like model, I call them a foundation model, because they can do general purpose tasks. They cannot do, they're not specialized. They are basically, they're pretty general in what they can do. Building a foundation model like that is an art. The problem with it is that when you're trying to improve a quality of a general purpose model, let's say you want this model to be very good with economy questions. You start improving the economy questions, then all of a sudden, you see that the math performance of the model drops. Physics performance of the model drops. So there's always a trade-off between how you're designing this system. And understanding that trade-off and building smart algorithms that can balance this kind of level of knowledge and speciality of the model, that's the art that we're trying to master here. So that's what we do at Liquid AI. We're trying to actually build up, now going to your next question, which is how can we actually get this quality? So that's the question that we're asking ourselves. The models that are going on devices, first of all, these models are smaller than the ChatGPT model. These models are general purpose, but they are smaller. We call them, instead of large language model, we call them small language models, SLMs, okay? So small language models, they can do general purpose. They understand language. That means they can reply to you for answering your your daughter's like homeworks, like they can address that. At the same time, they might actually give you financial advice in the morning. They're general to that extent that they can do that. But at the same time, they're not that general that they can cover all languages in the world, 150 languages in the world. They're smaller. They can do general tasks in language domain, vision domain, audio domain, like being able to communicate with humans. But they can do a little bit, like maybe small. So the art is that to get them to the quality that is satisfactory for all of, for the actual use within enterprises, for users, we need to specialize them. We specialize these small language models for them to bring ChatGPT quality value on device.
I want to interject a question here because you brought up LLMs, large language models, and we all know that they suck up a lot of energy. We are reading about how we're building new energy centers. The small language models don't do that as much, I believe, from the research I've done. Is there a way to quantify for us exactly how much more energy efficient and friendly increasing SLMs would be?
Absolutely. So training this small language model for today's world, they might be in the order of thousands of times like cheaper than what you would actually get from a large kind of language model that you would host it in the cloud. So you would save a lot in the development phase of it. But as I mentioned, even more important than that is that because you're running them on an end device, usage of this thing is unlimited. So you can unlimit, there's no API call. API, they have like rate limits. Why? Because you have to have like a lot more GPUs, and you have to enhance the number of GPUs every time the demand goes higher. But if you can actually host them on-prem, that would be basically an infinite amount of use. So the cost almost goes to zero.
You save a lot on your chip bill and your electricity bill. Well, I want to get to some real world examples. You have a variety of businesses. You're not a theoretical company. You have customers. Can you tell us, if you can, what are the needs that your customers are expressing, and how are those needs evolving? What problems are they asking you to solve?
Absolutely. So as I mentioned, category of the problems that we're solving today are falling into low latency applications of generative AI, private applications of generative AI, and low cost development of foundation models. So say, for example, someone wants to build a foundation model for fraud detection. So they have data, and their data cannot leave the enterprise. They want to build a foundation model for fraud. We come in, we basically train the model, and we host the model. So they can host it on their local kind of premise. Depending on the size of this model, depending on the degree of sophistication of their data, we can actually decide what to do. The other line of business is basically, as I said, like we have developed a library of foundation models that you can take and you can use them for edge AI applications. These foundation models, they come with different expertise. As I said, they're specialized. Some of them are financial foundation models. Some of them are going to be like using for document insights, extracting insights from a document, Some of them are good for powering your in-car intelligence. For example, right now, like you have cars, and in your car, you might have some voice-assisted kind of commands, but at the moment, they're kind of dumb, right? Like, so what you want to do, you want to supply the in-car intelligence. You want to actually like be able to interact with your car. So that's like one of those areas where automotive industry would be very interested in. There is another aspect which robotics and more different types of devices are entering our lives. For example, humanoid robots, right? And different types of robots for our smart cities in the future. So devices are actually growing at an exponential rate. And in each of these devices, you could actually integrate some sort of a liquid foundation model, which is basically the models that we're building in-house.
Is there a certain industry, and I'm asking this question on behalf of all the business leaders in this room, is there a certain industry that can most benefit from liquid AI and these neural networks right now? Like, say, is it manufacturing or transportation or information services or finance? Who's your, like, kind of sweet spot customer right now?
Yeah, so the starting point for us was companies that are having devices, volume devices, like let's say car companies, space companies, like companies that are building spacecrafts. companies that have consumer electronics, like mobile phones and stuff. So would be the barrier of entry. But then when we go to financial services, when we go to insurtech, when we go to places where data becomes very sensitive, that's kind of the privacy aspect of things that enables, again, local and edge AI deployment for the financial sector has been like a very important. The other sector is medical, for example, and hospitals, because hospital data is also extremely sensitive, you know, so it cannot leave the enterprise. So that's like another area. As I mentioned, the promise of generative AI as a whole, you know, is the fact that it is general, you know, and it is not just one industry that you can touch. You can go across industries. We are considering ourselves one of the foundation model companies in the world right now. Foundation model companies, there are not that many. There are basically a handful of companies in the world that can actually do this kind of job that I'm telling you. Companies like OpenAI, Anthropic, ourselves, Cohere, and apart from the big tech, that are focused on building general purpose models that can serve massive kind of demand. And our focus within this realm of foundation model building is on the edge deployment and local deployment, places where the cloud, the solutions on the cloud cannot cover.
So it seems that it does apply across industries, but that being said, is there a specific business use case that you are most proud of that stands out to you as a major accomplishment for the company?
There's a lot of them. So as I mentioned, like fraud detection, like that's one of those areas that we can build foundation models for that. We can build the future of a whole business. So think about, let's say, e-commerce. You know, in the space of e-commerce, if you think about it, in the future, you're gonna have, like right now, what is the shopping experience for you? You know, if you think about shopping experience, you go online, you look into like some online shopping. So you go check out some products, and then try to see like how to get to the thing that you like. In the future, you're gonna have an agent, an assistant, you know, on your phone. This assistant is going to, you can talk to that assistant. You can say, hey, you know what? I'm looking for this type of bag, and I wanna, you know, like I need it to be under $200.
Or clothing for 5-foot women?
Exactly, yes. So exactly, like those case. And then, so what do? You basically talk to this agent. Okay, this is an AI agent that you're talking to. This is an AI agent that is assisting the buyer, you. Then this AI agent, what does it do? It goes to a marketplace, right? In that marketplace, you have sellers. Sellers are not going to be humans. Sellers are going to be other AI agents. So the merchants' AI agents. So there you have AIs talking to AI. So that's basically a future that we can actually see happening in that space of e-commerce, for example, which is one of the largest ones. And we can see that truly we can build these specialized agents that, you know, benefit the buyer, benefit the seller, and you can see that market's emerging. So I think perhaps like this is like one of the most sensible places where everyone can actually allude to, but there are more sophisticated solutions also in the biotech industry, for example. There, I'm very proud to design like basically foundation models that can design new protein structures for drug discovery. So that we have done as well in-house. So when I tell you that we are a foundation model company, means that we can really go after, you know, selling bags and also designing drugs, you know.
Yeah, I have to say, by the nods in the room, apparently the men and the women are equally shopping online and looking forward to this agent. Okay, we're talking about the promise. Let's talk about the challenges and the trade-offs. What are the hard decisions around implementing edge AI? Is it cost? Is it speed? Is it you know, challenges of scale?
Yes. So fundamentally, there is a limit for. So when we talk about generative AI, you have always heard about these generative AI solutions like ChatGPT having billions or trillions of parameters. This means like the systems are very large. You know, even the small foundation models, the small language models, they're in the order of 1 billion to 10 billion parameters. So they are large. The challenge is that how can we bring in, that goes back to that question about like, can our devices of today support 10 billion parameter models running on that, on themselves, you know? That's one of the problems that needs a fundamental solution. Our fundamental solution was to changing the base. We are not building on top all the transformer-based, all the generative AI solutions that are out there are building these generative AI solutions with an architecture that is called transformers. So transformers is the core building block of foundation models. What we are doing, we are changing that into something different that we invented at MIT. We call this liquid foundation model. This technology itself, it allows you to reduce the cost, reduce the computational cost of billions of parameters interacting with each other to a minimum, to a fraction of those things. To give you some numbers, the number would be between 20 times to 1,000 times more energy efficient. So that you can actually bring that foundation models without loss of quality onto a device.
Ramin, how will our devices have to change? And explain how this works. Is, say, like Apple aware what you are doing and they are designing future models of their devices to handle this form of AI?
That's an excellent question. So one of our partners, AMD, for example, which led our Series A of financing as well. So we're partnering with them. So AMD, you can imagine, AMD is designing devices, across the world. They're building AI PCs, laptops that are powered by AI, right? So one of the interactions that we have with AMD is on the fact that, we are going to, it's a bidirectional kind of communication. We try to optimize our solutions for the AMD hardware or devices, but at the same time, when we go further, because pace of building a new hardware is a little bit slower than pace of building a new software, so we are informing also the next generation of hardware. So hardware is going to be adapting to this. And this is not just for AMD, but it is also for any kind of device manufacturer.
We are down to our last 5 minutes. Before I ask you to look ahead for us, I want to ask you about being in Boston, because we've heard about a lot of companies leaving. You named your competitors. They are the giants that you're competing against. So why were you, we know why you were born in Boston. Why are you staying here?
Well, the thing is, I believe in a global, structure. So I don't think the fact that you're rooted in Boston, it's amazing. Boston is a beautiful city to live in. It's a wealthy kind of, state, and I hope that more capital actually flow into the startups kind of scene, from our venture capital places and also local businesses. I think this is something that we need if we want to really truly transforming this. But at the same time, even from Boston, we are showing that we can actually build a global organization. Right now, the company is expanding. Right now, we have an office in San Francisco. We have an office in Tokyo. We are opening an office in Europe, in the heart of Europe. And that is all possible from a headquarters based in Boston.
So today, you already taught us, at least for me, because I had not heard of this before, this new form of AI. I now want you to look ahead a few years from now and describe what a fully scaled edge AI ecosystem looks like and what the role of liquid AI will be in that world.
One word, sovereignty. So you're going to be in control of your artificial intelligence. A lot of us are having this anxiety about one single company controlling our faith, right? So that's something that we want to avoid. So I feel like with Liquid, what we can do, if we start deploying edge AI solutions and bring the computation and the power of AI to the edge, what you're gonna achieve is sovereignty. You're gonna be in control of your own intelligence.
I just have to ask you this because, again, I started by saying a lot of us are scared of AI. Is it going to get out of control? Is it going to take away our job? Is it going to make our life where we're in servitude to it? Can you give us some reassurance and, again, a glimpse into the future around the fears that the average non-tech power player has around AI?
Yes, we are going to do our best. We know that the motion is right now, everyone is aspiring to building the most powerful AI system on the planet, and even going beyond human capability, AIs that can go beyond humanity. And we're going to see the first sparks of this thing probably by the end of this year from some of the players. But what we are doing, as I said, going back to the first thing that I started, the core mission of our company was ML done right. So machine learning done right. So what we are trying to do, we're trying to understand along the way of scaling machine learning solutions and AI solutions, we want to make sure that we understand at every step what we are actually building. Very similar to how we designed the engine for an aircraft or autopilot system for an aircraft. Right now, as a passenger, you go on an airplane, you sit there, the pilot actually put it on an autopilot, but you trust that. You take that for granted. How do you trust that technology? Because the designers and engineers who designed that technology completely understood, and they're like, like there are mechanisms to actually ensure they passed a bunch of tests in order to be able to, get productionalized at that level and be taken for granted. So what I would say is that like what we are trying to do is very similar. Along the way to building very powerful and sophisticated AI systems, we are going to make sure that we understand what we're doing.
And in that future, will it be pretty much every company, all industries that will need sort of that trusted automatic co-pilot?
I believe yes, because I'm a techno optimist. So I know that in the future we're going to have, it's an inevitable fact that we should accept that in the future we are going to have AIs that are going to be better than humans. Like they're more intelligent than humans. It's going to be an uncertain world. I wouldn't know all the answers. So what I know is that we definitely need to do this in a way that we stay in control. And that's what I can say. But in the future, I'm pretty sure if you have, let's say, an AI system that can do a job of a person better than a human, I'm pretty sure these AI systems are going to be adopted next to our society. But that brings in a massive challenge and a different panel to actually talk about this thing for hours and days and maybe years to come to really like understand how that future is going to look like.
As long as we remain the sovereign. That is our time. Ramin Hassani, thank you so much. And now, by the way, as he said, spending hours more learning about this, you can feel free to reach out to the company, because when I was prepping, I said there is no way we are going to be able to explain this in 30 minutes. But thank you so much. And he said he's happy to take your questions and calls online. And now I believe it is time for some pitches.